When we talk about climate change, it's easy to think of it as just one single problem, but it's not. It's much more like a massive domino effect. Today, we're going to trace that chain reaction, see how one initial push sets off this incredible cascade of events that's changing our entire world.
So here's how we're going to break it down. We'll follow the dominoes as they fall, starting with the Great Melt. From there, we'll look at how that's making our oceans rise, which in turn is unleashing some truly wild weather. And finally, we'll see how all of this puts life on the brink.
All right, let's start at the beginning. The very first domino. This is probably the most obvious and honestly the most dramatic sign that our planet is warming up, the ice. It is melting, and it's melting fast.
Just take a look at this. This really shows you the speed we're talking about. On the left, that's the famous ice cap on Mount Kilimanjaro in 1993. On the right, that's the exact same spot just 7 years later. 7! The change is just wow.
And if that picture wasn't enough, get this. Between 1912 and 2007, a whopping 85% of the glacial ice on Kilimanjaro just vanished, gone. That's most of a century-old ice field, wiped out in under 100 years.
And this isn't just happening on one mountain in Africa. It's a global thing. These maps are showing what's projected to happen to the sea ice up in the Arctic. I mean, just look at the difference between the late 1900s and what they're predicting for the end of this century. The trend is crystal clear.
Now, here's the really crucial part. Melting ice isn't just a symptom of the warming, it's also a cause. Think about it. Bright white ice acts like a giant mirror, reflecting sunlight back into space. But when it melts, it uncovers the dark ocean or land underneath, and dark surfaces absorb heat. So less ice means more heat absorbed, which means even more ice melts. It's a dangerous feedback loop.
Okay, so the ice is melting, a lot of it, and all that meltwater has to go somewhere, right? Well, it flows right into our oceans. And that's what tips over the very next domino in this chain reaction, sea level rise.
So why are the seas rising? Well, it's actually two things happening at once. First, the obvious one. You've got trillions of tons of new water pouring in from all that melting ice. But second, and this is a big one, as the ocean water itself gets warmer, it actually expands. It takes up more space. It's a basic law of physics, and it accounts for a huge chunk of the rise we're seeing. Now check out the curve on this chart. This is what's really interesting. It's not a nice, straight, predictable line, is it? It actually curves upwards, getting steeper and steeper. That tells us something really important. The sea level isn't just rising. The rate of the rise is speeding up. It's accelerating. To give you an idea of the scale here, the stakes, look at this number, 7 meters. That's about 23 feet. That is how much global sea levels could potentially rise if all the ice currently frozen in Greenland were to melt.
So what does 7 meters, or even just 1 or 2, actually look like for people? This map of Bangladesh puts it into perspective. The colored areas are where millions and millions of people live. And with just a few meters of sea level rise, all of that could be permanently underwater. This isn't some abstract problem. It's a direct threat.
Okay, so we've got warmer oceans, more water vapor in the atmosphere. You're basically adding a ton of extra energy and moisture into the system. And that's when the next domino starts to wobble, our global weather patterns. They're getting supercharged.
This map, this is just a snapshot of a single year, 2016. Every one of those little icons is a major climate event. We're talking record-breaking heat, insane floods, super powerful storms, massive droughts, and look, it's happening all over the globe. So you might be wondering, wait, how does warming cause both floods and droughts? It seems like a contradiction, right? But it's all about how water moves. Warmer air can hold more moisture, so when it finally rains, it can pour like crazy, leading to floods. But that same heat also sucks moisture out of the ground faster, making other places much, much drier.
So the main takeaway here is that climate change is essentially turning up the volume on everything. It's making the wet extremes wetter and the dry extremes drier. It's amplifying the whole system, making both sides more common and a heck of a lot more dangerous.
And all of this, the melting ice, the rising seas, the chaotic weather, it all leads us to the final domino in the chain, the one this has all been building toward. This is the impact on life itself, on entire ecosystems that are being pushed right to their breaking point.
We've all seen this image. The polar bear has become the poster child for this crisis, and for a very simple reason. Its entire life depends on sea ice. That's its hunting ground. That's where it finds food.
No ice means no food. It's that simple and that brutal.
But hey, this isn't just happening in the freezing Arctic. Let's go thousands of miles away, to the warm tropical oceans. When that water gets too warm for too long, corals get stressed out, and they kick out the algae that give them their color and food. That's coral bleaching. You're basically watching a vibrant underwater city turn into a ghost town.
And here's the thing to remember. These events don't happen in a vacuum. When you lose a key species like the polar bear, or a whole habitat like a coral reef, it sends shockwaves through the entire system. It messes up the food chain, it causes habitat loss for countless other creatures, and it reduces the planet's overall biodiversity, the very thing that keeps our world resilient.
So from the highest ice caps down to the deepest coral reefs, we've followed the chain reaction. We've seen how one single change can trigger another, and another, and another. It's a powerful reminder of how deeply connected everything is, which leaves us with a pretty heavy question to think about, doesn't it?